you heard it. I'm a car guy, so this is why I much appreciate that somebody put some cylinder head gaskets here as a decoration. And the company, as doesn't come as a surprise to you, is called Veecle. And I thought the best way to describe what kind of problem we're actually solving is by telling you the backstory, how it all came about. So picture this. It's 2018, and I was very happy because I just made a big leap in my career. I was able for the first time to combine this big passion of cars with my professional life. And I landed a faculty position in a renowned German university for automotive software security. So that's basically a professor who protects cars against hacking. And also lucky enough, in one of the first research projects, the client or the customer that we worked with was one of the largest car makers in the world, VW. And in one of these on-site meetings, I sat on the table during lunch with a manager, and his name tag said he's an onboard network manager. And I just had to ask him, I'm sorry, sir, I'm really, I have to ask, like, excuse my ignorance, but what is an onboard network manager? And he said, and let me try German accent here. So I have 1,200 people in my department that do decide about the length of cables, the color of cables, and the number of cables, and most importantly, the cross-section area of the copper in the wires. And I was stunned, because that told me that no one in this 1,200 people department had a clue of the overarching architecture of what kind of car they were building. And anybody in this room who knows about software knows that you cannot build a software if you don't know what you're building. So this felt to me like a jigsaw puzzle of people who were not allowed to look at the front of the cover of the box. And this moment was clear. I wanted to build a company that does exactly that, be the software architecture, being able to look at that front cover, be the front cover of that box so that other companies, car companies, can build this software architecture. And back then, I went to two of my PhD students and I said, I'm very sorry to inform you that this is the end of the career because I will quit my job. Are you going to do that with me because you're brilliant? And they sit in the audience, so you know we're 3 co-founders, so that worked out. And what we did with the very first funding when we founded the company is we bought a brand new car, latest generation, all the tech, all the checkboxes ticked. We drove exactly 0 kilometers with it, and we did this instead. We wanted to know how exactly do they work, what can we improve, how are they doing their software architectures in these cars. And that meant we went to an extent that probably nobody on this planet has done before, reverse engineering this car by desoldering the chips on the printed circuit boards, decompiling the software that runs on them. And we didn't expect what we found, because what we found was a time machine. A time machine that brought us straight to the end of the 90s. I'm not sure why it's going back, sorry. Maybe one slide is missing. And we saw this as an architecture that we were using. And you don't need to be a software architect to understand that this is not a good design. So it was clear to us that this is a wake-up call. We actually have a chance of changing the world by creating this, front cover of the box of this jigsaw puzzle. And we needed to understand when we built this company, what is the actual problem next to the technical problem from an organizational point of view. And if you look at how a car is built, there's one model, but they need to go to 30, 40 different supplier companies. So imagine one box is Bosch, one box is Continental, how they're all named. And they produce 150 or more of modules, of electronic control units for these cars, all running different software, written in different languages, and so on and so forth. So if a car maker decides to change a feature, or God forbid, add a feature, they have to go through this chain of cascade. And that means it's super slow. And if you're not called Tesla and had the chance to reinvent how this is done in the last 10 years, then they're stuck. And we're the first to basically finally give a central car operating system to these brands, give them for the first time the power so that they are in control of their software and of their features. And what we aim for is that other companies who build delivery services, ride-hailing, can use vehicles that they need for their service and program them the way they want to fulfill their business and create new businesses on top. The way this works, now we're talking about software architecture, is that we've learned how to talk to these legacy modules, but we give them an abstraction written in a very modern, high-level language called Rust. Nobody has done that before. We're the first. And that gives us an advantage in speed, because in Rust you can program much faster, because it is much more reliable and safe. And these functions, imagine like an app, are as easy like a smartphone app, then create these new businesses for car companies or for ride-sharing companies on top. And this means that we have this edge with this software because it's faster than what they're used to. It's, of course, updatable over the air so that they can come up with a new feature, and then within a couple of minutes, in theory, millions of cars can run this new software. And one important feature request also from customer side was that it is a white box solution. They no longer want to be dependent on these suppliers. So we give everything in the source code. And we also do come in very early in this classical process of how a car is engineered from ideation to prototyping to product. Believe it or not, what I saw at these companies in ideation phase is they use pen and paper or PowerPoint slides. We give them, for the first time, the ability to have a functional mock-up. They take an existing current architecture car, they add a new function, they can experiment with it, they can move it to prototyping phase, they can move it even to serious production. And in the best case, they don't need to edit the source code anymore. And we earn money because they use our software development kit, and it's basically a software as a service model. And when they go to production, for every vehicle they sell, we want our royalty. And what we've learned so far is it really pays off to be stubborn. If we had listened to the naysayers that said, you're a megalomaniac, you cannot build a car operating system, the big car companies can only do that, and you're using a programming language that is new and that hasn't been tried, let alone proven, in a safety-critical system like a car, then we wouldn't have ended up here. And now, interestingly, these choices from the past led to success in terms of partnerships, big car companies as customers, because this is exactly the features that they request. They say, we cannot use C++ anymore. It's outdated. We need a new language. We need a new model to build in. And yeah, thankfully, we sealed deals with big car makers that want to try out new features that they program in our system rather than in their system. And also partnerships that are very valuable with chip makers, because this is the first contact point for car makers. They know what they want to build, and they want to build it on this chip. And yeah, this is how we experience this kind of success. Yeah, thank you. I'm sorry.